Hi Balko, welcome to Narayana digital platform. I am Vikas Kumar and today we will be discussing 2nd September second shift mathematics mains paper. Bear in mind that these questions might be slightly different from the questions that actually occurred in the exam. These questions have been reconstructed using the memory of the students. So let's get on with it. The first question, we have to find imaginary part of this complex number. Note that these two complex numbers are conjugate of each other. Now, so the imaginary part of this complex number is same as twice imaginary part of this complex number. 3 plus 2 square root of 54 iota. I have written under root of minus 54 as square root of 54 into iota. Now, to the power half. Now, we know that this complex number we have to find, square root of this complex number we have to find. Let's take 3 plus 2 root 54. 54 iota 1 by 2 power 1 by 2 as x plus iota y. Squaring both sides, we will get x square minus y square plus 2xy iota as equal to 3 plus 2 root 54 iota. From here, we can say 2xy is equal to 2 root 54 and x square minus y square is equal to 3. Now, we might be thinking what can we do now to solve these equations, but looking at the options, we already know that we can take one of these as root 6. Which one? Since we can write root 54 as this is 3 plus twice of 3 into root 6. So we will take this as x and this as y. Bearing in mind x square has to be greater than y square. So our complex number is this is same as twice imaginary part of 3 plus root 6 iota. Again, bear in mind that this can be 3 plus root 6 iota or minus 3 minus root 6 iota, which means twice imaginary part can be 2 root 6 or minus 2 root 6. Here we have minus 2 root 6. We'll mark that. Moving on to the next question. In this question, we have three real numbers a, b, c, and these expressions are given. First of all, a cube plus b cube plus c cube is equal to 2 should remind you of a cube plus b cube plus c cube minus 3abc, and abc has been asked. So we know that a cube plus b cube plus c cube minus 3abc, which is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. Now, we know a cube plus b cube plus c cube, we have to find abc. If we have any information about these numbers, our job is done. For these numbers, we'll look at this. It's been given that AA transpose is I. What we'll do is we'll find AA transpose. AA transpose will look like, the diagonal elements will be a square plus b square plus c square. And all other elements will be AB plus BC plus CA. We'll write AB plus BC plus CA. All other elements will be AB plus BC plus CA. Note that since this is identity matrix, which is 1 0 0 0 1 0 0 0 1, we have a square plus b square plus c square as 1 and AB plus BC plus CA as 0. From these two, we can find a plus b plus c, as a plus b plus c whole square is a plus b plus c whole square is summation a square plus b square plus c square plus twice summation AB. AB plus BC plus CA. This we have 1, this we have 0. So A plus B plus C is either plus 1 or minus 1. Putting these values here, we'll get ABC either as 1 or 1 by 3. 1 by 3 is given here, we'll mark that and we'll move on to next question. In next question, there is a binomial expansion of 1 plus 1 by x to the power n, and consecutive binomial coefficients are in the ratio of 2:5:12. We know that in this binomial expansion, the coefficients are, let us take the coefficient as NCR minus 1, NCR and NCR plus 1. And let us take the ratios. These ratios are given as 2:5:12. First writing as NCR upon NCR minus 1 as n factorial upon r factorial n minus r factorial upon n factorial r minus 1 factorial n minus r plus 1 factorial. This expression will come out to be n minus r plus 1 upon r, and this is given as 5 by 2. This will give us the first equation, 2n minus 2r plus 2 is equal to 5r. Let's take it as first equation. Again, we'll apply the condition here, NCR plus 1 upon NCR. This is same as above. In place of r, we have r plus 1. So, we'll write as n minus r upon r plus 1, and that is given as 12 upon 5. Again, this will give us second equation. Notice we have two equations and two variables, n and r. We'll substitute r from here to here, we'll find n, and will come out to be 118. We'll mark that and we'll move on to the next question. Next question, there are n stations in a circular path, okay? Then consecutive stations are connected by blue line and non-consecutive stations are connected by red line. Let us say this is the circle, A1, A2, A3, so on, and let us say this is AN. So, how many consecutive stations are there? Consecutive stations, as you can see, will be equal to, so consecutive will be n and non-consecutive will be connected by red. So, we can see non-consecutive A3 to this, A3 to this, many connections will be there. So, non-consecutive connected by red lines. How many red lines will be there? So, we know that total lines are, so red lines, total lines which can be obtained like this is NC2. If we subtract all blue lines, will be red lines. We know that number of red lines is equal to 99 times number of blue lines. So, NC2 minus n is equal to 99 times n. Solving this, we will get n into n minus 1 is equal to 200n. Cancelling n can't be 0. Always before cancelling we should check n can't be 0. N is 201. We'll mark that. We'll move on to the next question. We have an integral 1 to 2, 2x minus greatest integer of 3x. It's been written, square brackets have represent greatest integer. Now, let us first write 3x greatest integer as 3x minus 3x fractional part. No problem. Substituting it back, 2x minus 3x greatest integer is minus x plus 3x fractional part. Applying mod. Now we have to decide which of these two is greater. Notice that greatest integer always remains in the range 0 to 1, whereas x it's given varies from 1 to 2. The integral is from 1 to 2, which means in this case x is greater. So we'll write this mod as x minus fractional part of 3x. After writing that, we'll substitute. Now this we have to integrate from 1 to 2. Integral 1 to 2 x minus fractional part of 3x dx is equal to. Now here we can go a little bit fast. X square by 2, x integral is x square by 2, from 2 to 1 it's 3 by 2 minus fractional part. As we know, the average value of fractional part function is always half. We are integrating it from 1 to 2, 3 times its period, which means it will be half. Answer will be 1. No problem, we'll mark that and we'll move on to the next question. Here we have been given a hyperbola, an ellipse, and eccentricities are follow this relation, means eccentricity of hyperbola is greater and obviously root 5 times eccentricity of ellipse, and we have to find latest rectum of the ellipse. Notice that eccentricity of hyperbola depends on is a square plus b square upon a square. For hyperbola, a is 1 or 10. For so we can write it as 1 plus cos square theta upon 1 under root, as 10 will actually cancel from numerator and denominator. This is root 5 times, this is equal to root 5 times eccentricity of ellipse. From here you can see x is the equation of ellipse, you have to see it's x square by cos square theta, in fact 5 cos square theta, but again that root 5 will cancel, so let us just write, plus y square by 5 is equal to 1. Notice that this 5 is greater than this 5 cos square theta, it will play the role of a, so it is root 5 times 1 minus 5, actually minus 5 cos square theta upon 5, 5 will cancel, 1 minus cos square theta under root. Solving it, we will get 2 minus sin square theta is equal to sin square theta is equal to 5 sin square theta, which means we will get sin square theta as 2 by 6, which is 1 by 3, or cos square theta as 2 by 3. This will play the role of a square, this will play the role of b square for the ellipse, and we have to find latest rectum. So latest rectum, we have the formula twice b square by a, putting the values, twice, what is b square? 5 cos square theta, so 5 into 2 by 3, cos square theta is 2 by 3, upon a is root 5. Substituting everything, we get 4 root 5 by 3, which is here. We'll mark that and we'll move on to the next question. This is a short one. We have a limit tan, quite straightforward, tan pi by 4 plus x to the power 1 by x. Writing in the limit again, it is limit x tends to 0, 1 plus tan x upon 1 minus tan x to the power 1 by x, which is same as, we'll write as limit x tends to 0, we'll write as 1 plus 1 minus actually 2 tan x upon 1 minus tan x, 1 plus to the whole power. Now the power was 1 upon x, will take power 1 minus tan x upon 2 tan x and then raise the whole to power 2 tan x upon 1 minus tan x. And we won't forget x also. This x. Notice that this entire base is tending towards e, and the exponent, this is tending towards e, and the exponent is tending towards 2. Our answer will be e square. It's there, we'll mark that, and we'll move on to the next question. We have a quadratic polynomial, one root is 3, and the relation f2 plus f minus 1 is equal to 0 is also given for that quadratic polynomial. Now, we don't know the leading coefficient of quadratic polynomial, but in this case, let us take it as 1. We'll start as fx is equal to x minus 3, one root is given, and x minus alpha. Notice that if you don't take that as 1, everything will come in a ratio. Nothing much will change. Then we apply this condition, f2. What is f2? f2 is 2 minus 3, 2 minus alpha, plus f of minus 1. What is f of minus 1? Minus 1 minus 3, minus 1 minus alpha is 0. We find the value of alpha from it. How much is it? It is alpha minus 2 plus 4, alpha plus 4 is equal to 0. From here we know alpha is minus 2 by 5. Now, the other root lies in, alpha is the other root, it lies in which of these intervals? Clearly, this number lies in this interval. We'll mark that and we'll move on to the next question. We have a differential equation here. Let's try to write the differential equation in different forms. Writing it as dy by dx is equal to or plus, we will have y upon x. So, we'll write it as minus y upon x is equal to y square upon 2x square. If we concentrate on this, it's a Bernoulli's differential equation, dividing everything by y square and taking minus 1 upon y as z. We'll convert into a linear differential equation. How it will look like? It will look like dz by dx plus, here 1 upon y will come after dividing by, and it minus 1 upon y will take as z, z by x is equal to, y square will disappear from here, 1 upon 2x square. Now it looks more familiar. Now, if you calculate the integrating factor of this linear differential equation now, it will come out to be just x. And you can see x dz and z dx also if you multiply by x. So, after multiplying by x, this will become differentiation of zx, and that side will become 1 upon 2x dx. Solving it further, we'll get zx, z actually is minus 1 upon y. So, minus x upon y is equal to half of ln x plus c. We have to find c, for which the curve passes through the point 1, 2. If you put x is equal to 1, y is equal to 2. So, c will come out to be minus half. So, this expression will become minus x upon y is equal to half ln x minus 1. Now, we need f half, or we need value of y when x is half. Putting x is equal to half, this negative sign will cancel, minus 1 by 2 y is equal to 1 by 2 minus ln 2 minus 1. Negative sign will cancel. 1 upon y is coming out to be ln 2 plus 1. So y is reciprocal of that, which is 1 upon 1 plus ln2. We'll mark that and we'll move on to the next question. We have been given 3 pairwise independent events such that A intersection B intersection C for those events is 0, which means, so it's better to draw the Venn diagram. Let's draw the Venn diagram. Events are like this, pairwise independent, but overall intersection is 0. There is no overall intersection. A intersection B intersection C is 0. Let's take it as A, B, C. Now let's see what has been asked. P of B complement intersection C complement upon A. Applying the formula, this will become P of A intersection B complement intersection C complement upon P of A. If you look at this set, A intersection B complement intersection C complement, you'll know that we are talking about this area, the probabilities corresponding to the events lying in this region. How can we write this region? This region we can write, as we know that A intersection B intersection C is 0, we can write P of A minus P of B intersection A, which is this region, minus P of C intersection A, which is this region, upon P of A. Now notice, pairwise the events are independent, which means P of B intersection A upon PA is simply P of B, and P of C intersection A upon PA is simply P of C. So this becomes PA upon PA, which is 1, minus this is PB only, and this is PC. Either you can write it as PB complement minus PC, or you can write it as PC complement, 1 minus PC is PC complement minus PB. This expression is given right here. We'll mark that and we'll move on to the next question. Now, here we have a series and we have 9 terms of that series, and the sum of those 9 terms is already given to us as an expression in x, k, x, a and numbers. We have to find k, the term in this series. Notice that x, x square, x cube, 9 terms, this sum will be x to the power 9 minus 1 upon x minus 1, which is x to the power 10 minus x, which you can recognize from here. So we are moving in the right direction. Plus ka, k plus 2a, k plus 4a, we can take a common. It's sum of 9 terms of AP only. It will be 9 by 2, 2k plus n minus 1 d. N minus 1 is 8 and d is 2. And this expression is given as this expression. Now, from these 2 expressions, can we simply say that this we can see here? Now, we have to compare this expression to that expression. After taking LCM, after cancelling this 2 and after taking LCM, obviously we will have 45a is equal to 9a into this k plus 8. So 45 is equal to 9 into k plus 8. 5, k plus 8 is 5 and k is minus 3. We'll mark that, minus 3 is visible, and we'll move on to the next question. Point P, now it's we have vectors here. Point P divides this join of A and B in the ratio lambda is to 1. So let us say this vector is A cap, this vector is B cap. Position vector of point P, let's take as P cap. Whatever is given to us is given as B dot P cap is minus 3 times A cross P mod whole square and this expression is equal to 6. Note that A and B are given to us. P involves lambda. So what is the position vector of P? We'll say P is equal to lambda B plus A upon lambda plus 1. We can take, now we'll put this vector here. Notice that it will be B dot P. B dot P will be lambda mod B square. We know mod B square because we know B, plus A dot B upon lambda plus 1 minus 3 times A cross P. A cross P is A cross B here, and A cross A is 0. So lambda A cross B, so lambda square A cross B mod whole square upon lambda plus 1 whole square is equal to 6. Notice that the whole expression has only one variable, that is lambda. Right here, mod B square we know, A dot B we know, A cross B we know because A and B are given vectors, and then we'll solve for the value of lambda. Lambda will come out to be 0.8. We'll mark that and we'll move on to the next question. Now we have an area question. Y is equal to alpha bisects the region given by these expressions. So let's draw this region. This is y is equal to x square and y is equal to 2x line. Let's draw y is equal to 2x line. We have to draw. Notice that this is a rectangle and this point is 2, 4 where both the curves are meeting, and this area it's being talked about, and this line, a line horizontal as y is equal to alpha, bisects this area, which means this area and this area both are equal. How to find this area? Better way will be to use horizontal strip, integrate this area segment, small area. This will be integration of y1 to y2. y1 will take as y is equal to 0, y2 will take as y is equal to alpha into this function minus that function. Now these functions are in terms of y. The first function, this function is y is equal to x square, hence x is equal to root y. So we will take root y minus this is y is equal to 2x, hence x is equal to y by 2 dy. This is the area, this area which I have written is area of this region, and this area of this region is half of the total area bounded because it bisects the area, y is equal to alpha bisects the area. Now what is this total area? Notice that this area is 8, the area of this rectangle, it's a rectangle, is 8. This area is 1/3 of 8. As you remember, the result, this area is 2/3 of 8, and this area bounded by this line and parabola will be 1/6 of 8. So this is equal to half of that area, 1/6 of 8. 1/6 of the area of rectangle is area of this region, and half of that is this integral. This we already have. Now we'll integrate root y to get y root y, we'll get alpha to the power 3 by 2 from here, alpha square integration of y will be y square by 2, we'll get y from here, and we'll look which of these following is matching. We'll mark it, we'll move on to the next question. Again we have a trigonometric equation, but it's not, the expression is defining lambda and range of lambda has been asked. So we'll write lambda is equal to minus of sine to the power 4 theta plus cos to the power 4 theta in bracket. This let us take it as f theta, and immediately we should recognize that f theta is same as f of pi by 2 minus theta. If you replace theta by pi by 2 minus theta, there is no problem. Sine power 4 will become cos power 4, cos power 4 will become sine power 4. and it is also same as f of pi theta plus pi by 2. Let's say it like theta plus pi by 2. From this, we know that it's symmetric about x is equal to pi by 4. And from this, we know that capital T, the function is periodic with capital T is equal to pi by 2. So, whatever we do in first quadrant will be repeated in every quadrant. The range will be the same. The range in first quadrant, we can see that since it's symmetric about x is equal to pi by 4 and we expect it to have one extremum at pi by 4 and another we expect at 0 and pi by 2. Both values will be same. F0, if you can see, is 1. In fact, minus 1, we have minus sign here. So, we have minus 1 and f pi by 4 is minus half. We have this set right here. We'll mark that and we'll move on to the next question. We have y is equal to summation of this and we want to find, let us check that I haven't skipped a question. Yes, okay. Summation k, okay. Now we want dy by dx. Notice that k is right here, cos inverse of an expression that looks like cos a sin b minus sin a cos b or cos a cos b minus sin a sin b. So let's write it as k times cos inverse cos theta cos kx minus sin theta sin kx, where cos theta we has taken as 3 by 5 and sin theta is automatically 4 by 5. This expression looks like cos a plus b. So it is cos inverse cos a plus b, which you can directly write as a plus b. So this expression y is simply summation of k is equal to 1 to 6 k kx plus theta. Notice that theta is a constant. K theta also is a constant. The only variable is x. Y dash will only contain the coefficient of x, which is k square and summation of it. So y dash will be equal to summation k is equal to 1 to 6 k square. You can very well find that. How much is it? It is 6 into 7 into 13 upon 6, which is how much? 91. We'll mark that. We'll move on to the next question. Here we have A1, A2, A3, A11 and increasing AP. We'll underline that so that we don't forget. And if variance of these number is 90, what is variance? Let us decide which formula to use. Then the value of common difference of AP. Okay, we want to find common difference, D of AP. So let us write this expression as A1 plus D dot dot dot, and 11th term will be A1 plus 10D. Mean will be equal to the middle term only in the case of arithmetic progression. It has 11 terms and hence the mean is the middle term. Middle term is A1 plus 5D. And let's use the formula summation of xi minus mu whole square upon n is given to us. N is 11 only, it's 90. Let's use this formula. Xi is these numbers and their difference from A1 plus 5D, for first number is 5D, next number is 4D and so on. So this will be equal to 5D whole square, 4D whole square, dot 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 0 dot 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 5D whole square. 11 terms and we'll multiply 11 there, 19 to 11. We'll take D square common. Twice the sum of the squares of first 5, D square into twice the sum of squares of first 5 natural numbers, D square into 2, sum of squares of first 5 natural numbers is 5 into 6 into 11 by 6, which is equal to 90 into 11. Many things to cancel. We have D square is equal to 9 and D is equal to plus minus 3 Now we'll remember this increasing, we'll mark d is equal to 3. And we'll move on to the next question. Equilateral triangle is inscribed, it's not increased, it must be inscribed. As you recall, these are questions we know about from the memory of the students. So it is inscribed in this parabola y square is equal to 8x, whose one vertex is vertex of the parabola, and okay. So we'll take, let us say this is the parabola and it's an equilateral triangle. Let's draw an equilateral triangle, nearly equilateral, will serve the purpose. This angle, as we know by symmetry, will take as 30 degree. This point as general point on parabola can be taken as at square comma 280. At square is 2, so 2t square comma 280, yani 4t, which means this distance is 4t, this distance is 2t square. The ratio is tan 30. So tan 30, which is 1 upon root 3, is same as 4t upon 2t square. This will give us t as 0, which is for this point, not for that point, or t is equal to 2 root 3. Putting back, this point will be, this point is 2t square, which is 24, comma 4t, which is 8 root 3. Notice that we have this height as 8 root 3, this as 24. The area of this equilateral triangle will be twice the area of this triangle. It will be half of the product of this. Twice half, we can just take product of these. It will be 192 root 3. We have it right here. We'll mark that option and we'll move on to the next question. Next, we have given fx as ln of 1 plus x upon x in its domain -1 to infinity. As we have taken 0 is inside in domain by defining f0 is equal to 1. Then fx is, we have to comment on increasing or decreasing, whether in which interval function is increasing, in which interval the function is decreasing. What we'll do is, we'll differentiate the function f dash x. For increasing, decreasing, we'll differentiate the function. F dash x will come out to be x square x upon 1 plus x minus differentiation of x and ln 1 plus x. Now we have to decide whether the numerator is positive or negative based upon which interval we are. The numerator, denominator is always positive, we can ignore that. Numerator, let us take as gx. So we will be like gx upon x square. And let's concentrate on gx now, because whatever is the sign of gx is the sign of f dash x. Gx will again differentiate. G dash x will come out to be differentiation of this. This expression we can write it as 1 minus 1 upon x plus 1. Its differentiation will come out to be 1 upon x plus 1 whole square minus this expression will come out to be 1 upon 1 plus x. As you can see, this is x upon minus x upon 1 plus x whole square. Again, denominator is positive. Notice that for x greater than 0, this expression is negative. Since g0 is 0, for positive values of x, it is decreasing. After 0, it will become negative, which means f dash is negative after x is equal to 0, which means the function is decreasing. So we have two intervals, -1 to 0 and 0 to infinity. So after 0, f dash is negative, the function is decreasing. Let's talk about before 0. Before 0, x is negative, minus x is positive, which means gx is increasing. Gx is 0 at 0. Before 0, it must have been negative, that is why it is increased to 0. So again, g is negative, which makes f dash negative, which makes f as decreasing. So it is decreasing in this interval also. So overall, we have decreasing in -1 to infinity in its entire domain. We'll mark that. We'll move on to the next question. Again, we have an expression. It's a curve, and we have to find equation of normal at 0. First, let us find the value of y at 0. We'll put x is equal to 0 here. This will be sine inverse 0, which is 0, cos square 0, which is 1. 1 plus 0, it's 1 to the power 2y, any power, it will be 1. So for x is equal to 0, y is 2. So the point we need to find the normal is 0, 2. Then we'll differentiate this. Differentiating this, y is equal to, it will be like e to the power 2y ln 1 plus x. Differentiating, we'll get the same term first, plus x to the power 2y, and then we'll differentiate for 2y ln 1 plus x, which will be 2y dash ln 1 plus x plus 2y upon 1 plus x. Then we'll differentiate this term, cos square sine inverse x. It will contain minus 2 sine of twice of sine inverse x multiplied by the differentiation of sine inverse x, which is 1 upon under root 1 minus x square. Now we'll substitute 0, x is equal to 0 and y is equal to 2 here. X is equal to 0, this term is 0, ln 1 is 0. X is equal to 0, this term is 0. We'll only have this term is 1 and this term is 2y, y is 2, so this is 4. So y dash, this is y dash, we are differentiating. Y dash is coming out to be 4 at 0, 2. But slope of normal, m normal, will come out to be negative of reciprocal of 4 minus 1 upon 4. Which of the lines given here have the slope of minus 1 by 4? We have these two lines, x plus 4y is equal to 2, x plus 4y is equal to 8, but the normal must pass through that point 0, 2. Which of these lines passes through 0, 2? Clearly it is this line. We have our normal. We'll mark the option. We'll move on to the next question. Now, this says which of the following is a tautology? We have given many expressions. Now, as you remember from a tautology, like an implication, let us say A implies B is there. Tautology is always true, irrespective of the variables, truth values of the variables. Now, in this expression, let us consider first, it is of the form A implies B. A implies B can only be falsified if A is true and B is false, which means we already know the expression is true if Q is true. Q is true, the case is already taken care of. The expression is true. We only need to consider the cases in which Q is false. If Q is false, we take two cases, P is true or P is false. P is true means the first expression is false. False implies false is true. If P is false, then false intersection false. This expression is false. Again, false implies false. Whole expression is true. So whether Q is true, whether Q is false, the entire expression in both cases is true, which means this right here is a tautology. If this is a tautology, we need not check other options. We'll mark that option. We'll move on to the next question. Now, in this question, we have been given sum of 11 terms of AP is 0 and sum of this term is in the form of A1. We have to find K. We have to find some of these terms in the form of K, in terms of KA1 or A1. Let's do that using this. A1 plus A2 plus A3 we'll write as A1 plus A1 plus D plus A1 plus 2D dot A1 plus 10D is given as 0. This means 11 terms, 11 A1 plus sum of first 10 natural numbers is 55. 55D is 0. We have first expression. Let's call it as first expression. What we need here, let us see, is A1, A3, A23. It has how many terms? It has 12 terms. A1 plus 22D and common difference is 2T. We will be like 12. The sum is 12 by 2 A1 plus 11 into 2D is equal to KA1. What we need to do is, using this expression, we'll put D as minus 11 by 55. We'll put here and we'll find the value of K as coefficient of A1 here. The only variable is K, we can easily find out. We found out it will come out to be minus 72 by 5. We'll mark that. We'll move on to the next question. Here's the next question. Here we have a matrix X, and capital A is set of all such matrices X such that Px is 0, whereas P is this matrix. This matrix might be different from what actually came in the exam. Let's still move forward. Let us see. The number of elements in A is, how many such X are possible such that Px is equal to 0. One more thing was given in the exam, that x square plus y square plus z square is 1. Somehow we managed to not type that, but still consider this as a part of the question. X square plus y square plus z square is equal to 1. So one expression was given, and if you multiply P with x, we will get two more expressions, 2x plus y plus 2z is equal to 0, that means Px is equal to 0, and x plus y plus 2z is equal to 0. Using all this, we will find the values of x here, and we know that once we find the values of, let us say, y and z, we will find the values of x by z and y by z. We know that x is coming out to be 0, and since we can similarly we can find the ratio of y is to 2, it will be minus 2 is to 1 and so on. The ratio is given. Now here if we substitute the values, we will get a plus value of the ratio, a minus value of the ratio. We will always get two sets of x, y and z irrespective of this matrix. This matrix need to be a scalar, need to be a singular matrix. We will mark exactly two elements and we will move on to the next question. In this question, we have a point sin theta comma cos theta. This point lies on the same side as this point of the line, x plus y is equal to 1. We know how to do it. We will write sin theta plus cos theta minus 1 multiplied by 1 plus 2 minus 1. This should be greater than 0. Now we have to solve this trigonometric equation. This simply leads to sin x plus cos x is greater than 1. Where is sin x plus cos x greater than 1? In entire first quadrant, sin x plus cos x is greater than 1. Whereas in second quadrant, it's not that. It's given here, the first quadrant, 0 to pi by 2. We'll mark that. We'll move on to the next question. Next, we have these two vectors, and the vectors are in plane of this point must be 3, 1, 1 because it's a point, and alpha, we have to find alpha such that these 2 points also lie in that plane which contains these two vectors already, which means if we join these 2 points, that vector must also lie in the plane. So we have 3 vectors in a plane. The 3 vectors are 1, minus 2, 2, 8, 5, 1, and other vector is alpha minus 3, minus 3 minus 1, 5 minus 1. These 3 vectors lie in a plane, hence this determinant, their triple product must be 0. As we can clearly see now that this first row and the last row bear much resemblance, just twice, if you multiply that with 2, we will get this. If alpha minus 3 is 2, we are done. And alpha is 5, we are done. We can only report one value. We will report from here alpha is equal to 5, and we will move on to the next question. Next question we got quite at the last moment. Let us see. We have been given a function fx plus y is equal to fx plus fy. From that we know that function fx is of the form kx. Fx is equal to kx. F1 is given as 2. F1 is 2, then fx is kx, then k must be 2. So fx, from these two informations, we know that fx is equal to 2x. Fx is 2x. Now, this fx is a continuous function that may or may not have been given, but it's better to include that so that fx is 2x only. Gn is defined as gn is equal to this summation. This summation will be summation of r is equal to 1 to n minus 1 to r, and that is given to be 20. We have to find n such that summation r is equal to 1 to n minus 1 to r is equal to 20, because fr is 2r. Finding n, what we will do? This summation is twice of n minus 1 n by 2, which is equal to 20. We can clearly see that n minus 1 is how much? Is 5, and the value of n is 5. We have that as an option, and we are done. And it's the last question. We are done with the paper also. So I hope the questions are almost correct, but we will only get to know after the results and final key. That's all for today. Thank you very much.